And okay, friends, good morning. What is this? What I'm going to do today? So, just going to take you into a travel of a slow transition into a hyperdimensional space. So, as you can see from here in GeoGebra, you have a 3D collection of points. As you can see, when I just put it is very easy for you guys to imagine the dimensions in 3D. So, it is so simple. I will just explain you with this thing that when you just see like this, it is you have one in the x direction and one in the x direction and one in the y direction and z in the other direction. Okay, so there are all lots of uh, things that are going over here. So this is very easy to imagine. There is no problem with this. Okay, so there is no problem with this. Even when you just imagine this thing in this hyperdimensional space, you can see that you can see over here. Oh, it's an and you can see over here. So this is a point in hyperdimensional space where these points corresponds to the plane coincidence. When I just show you where are these points, so in C is supposed to be an Z. So when you just put it over here, you can see the point is in the space. So it is very easy to imagine a 3D space. Okay, it is very easy to imagine a 3D space. You have X, Y, and Z. The only thing you have you have almost you have almost Z in this direction and X in this direction and Y in this direction. Okay, so if you want to imagine 1 in Y, you just tell it as 1, and in X you tell it as 2. Okay, and Z you tell it as 3. Then these points all will combine to form a cube over here. Okay, these all points will combine to form a cube over here, and you can say that in X it is 2, in Y it is 1, and Z it is 3. Okay, so this is what I am telling. It is very easy to imagine 3D space. But what about a 4D space? What are the softwares which will aid to make you imagine the 4D space? So let me show you one example. Let me show you one example here. So tesseract. What is this tesseract in 4D space? So it is uh, very not that very easy to just imagine it, and it is very complex to understand the tesseract and these 4D dimensions. And there are lots of tutorials which are being going, and then in movies also it has been buzzed a lot. Okay, so how to imagine this tesseract in a manner that in a normal sense they have taught you in the schools and colleges. So let's see about that. So this is the tesseract which is deforming into and getting into a shape. Okay, so this is the 4D cube. The 3D cube would be like this. The 3D cube is so simple, would be like this. Okay, and you have to note that this is orthogonal, that is, it preserves 90 degrees. Okay, this is also orthogonal. So this is the W direction, the diagonal thing is W, and this is X, Y, and Z. Okay, so it is also 90 degree, but your mind cannot visualize the 90 degree. Okay, your mind cannot visualize the 90 degree. Okay, so I will show you in software. So you have a software on here and another software over here, as you can see from this. So in this software, everything is in 3D. Okay, everything is in 3D. You have a blobby shape, a topological space is in 3D. You can just view many things. Okay, you can just view many things. When you just compare There are lots of blobby shapes and different kinds of shapes, as you can see here. Okay, so these are all in 3D. Okay, so I will tell you a thing. Why we cannot imagine the 4D and why it is impossible to do. So let me take you to the higher dimensions, ND, okay, on the equation. So this is the hyperdimensional space. I am activating the 4D. So this is the 4D. So when I just go for a rotational plan, okay, it just can't, it just shows you how it rotates in 4D and all those things. Okay, so this is another surface in the fourth dimension. Okay, so it is very difficult to imagine the 4D, and there have been a lots of tutorials on this 4D and all those stuff. Why is this so difficult to imagine the 4D? Is because you must realize that this is 90 degrees only. This is really about 90 degrees only. When I just rotate in the YZ plane, it rotates like this. I will show you. Okay, it rotates like this. In the YZ plane, it rotates like this. Okay, it rotates like this. If I show you this in XY, it rotates like this and it rotates like this. And if I show you in XZ, it rotates like this, this and this. It takes the degrees of freedom. But when I just show you in XW, what happens, you see? It is going inside and coming out. So this is my hand, this is the inside of my hand, this is outside of my hand. You can consider this as green part and this is as that yellow part. And you can see it is going in and out. So I will show you another space. Even these curves also, in this you can see that these are getting wrangled up. Okay, these are getting entangled and wrangled up. So you can see in any position that these are getting inside and out. If you see, if you take an part of even this a Klein's bottle, you can see that in XW direction it is going in and out. Why is this deformation? You can just view, and if you just go to a very higher dimensional space, for example, you can just go to a very higher dimensional space, you can activate even ND, okay, even in the fifth dimensional thing, you can activate it. So you have to, in order to activate it, you should go here, okay. So I will tell you something. So go to the tools and parametric, I'm sorry, deactivate this and get back to the ND. And as you can see, 3D morph rotations also you have to deactivate it, okay, in parametric, the rotational plans, and get back here, deactivate this and activate the 4D. Even in the 4D, you see what happens. In XY plane, it rotates like this. It rotates like this. And in the YZ plane, it almost rotates like this. Okay. In XZ plane, it rotates like this. So it is just a normal rotation without going inside and outside. Okay. Like inside and outside. But when you just take the XW, what happens, you see? It is going inside and outside. It is going inside and outside. One is visible in the 3D and other one is not visible in the 4D. That's why this is happening. When you just go to YW also, it will just deform in the YW direction. It goes in and out. In ZW also it happens like that. Okay, in ZW also it happens like that. It goes inward and out in ZW, in Z direction. But when you take this xt, also the fifth dimension also it goes like that. Yt in fifth dimension also it goes in and out. But when you take two things, 4D and 5D, you can see it is contracting and retracting like a heart, our heart. You know why? Because these two dimensions are not visible in our three dimensions. Okay, so you can't see that, but the contraction would really take place. Okay, so this is the method I can tell you so far. So you can try this after. Even if you take 6D, you take a 6D plan, okay, and you go over here, XS is supposed to be in and out. Okay, XS is supposed to be in and out, and YS is also supposed to be in Y direction, in and out, and this is also in this direction, it is in and out. But WS, which is just contracting, and retracting, W is in fourth dimension, S is in sixth dimension. If you take fifth and sixth dimension also, it will be retracting and contracting. Okay, you don't know why this happens. Okay, it just retracts and contracts. It just retracts and contracts. Even you take for a simple thing like this. Okay, you take for a simple thing like this, and you just deactivate these things and just do in this manner. It just goes inside and outside. It just goes inside and outside. It just goes inside and outside. So this is how the fourth dimension is visible in this software. And you take another software, this is the tesseract. So when I just tell you in X direction, if I plot 1, you can see that, let me reset the things, reset all things. If I just plot in X direction as 1, what happens you see? So it is getting into this part, it is just moving to 1. And when I just put 1 over here, it is just moving down. So in X it is 1 and Y it is 1. And in Z also it is 1. But when you take the W, you put 1, or you just increase it, it goes back and forth. It just goes back and forth. If you just put minus, it just put minus in W. Okay, when you just put minus 1 and you just get over here, it just goes front and back. It just contracts. So you have all those things in this. Okay, you have all those things. So you have this so-called tesseract, in which you can deform the objects and see. Okay, so this is the rotational. So in YW it just rotates like this. In YW, in ZW it rotates like this. In YW it rotates in this manner, and XW it rotates in this manner. So this software is, I got this from a very old thing. Okay, old software, and you cannot get this now. This was released in 2001. I just got it that time. I was very interested in 4D, so I just got it, and I don't know what to do with this. Okay, so I am just introducing you to this software. So you can try most of these things, but you can't get this software now because it is under license, or it cannot be uh, downloaded. Okay, so you can see here in X I am just increasing, the cuboid moves to left side. If I am increasing in Y, it moves to the upward, and in minus it moves in the opposite direction. In Z it goes beyond, and in W the green part is diminishing. So this is the W part, and this is the X, Y, and Z. So this is how you have to view. Even the minus, if you say there is a negative time, even if you just do this negative dimensions, you can see. Okay, still now I am telling you that we have just gone through many things about 4D, and I can also tell you there are even non-integral dimensions. Okay, there are also non-integral dimensions. Okay, so this is the non-integral dimension. As you can see, this is exhaust, and you can see over here, uh, this is an software to zoom speed. So let's set it to 5. So it will be very speed. So you can see here, this has a non-integral. Instead of curvilinear, it is non-integral, and it is also one of the curvilinear thing with non-integral dimensions. So you can go here, go for a tutorial and introduction to fractals and whole story. Let's look for the whole story. So this is the thing. This is the story what they are telling. Okay. So what are fractals? So fractals, what is a fractal? Benoit Mandelbrot discovered it. The fractal sets in a topological dimensions strictly exceed it. And there's also a lot to tell about the fractal things. Okay. So you can see here, there are lots of mysteries around this fractal thing, that I can only tell you that I made a own proverb of myself, that loss of consciousness is the mistake, not loss of perfection is the mistake. Okay, this is what I can tell you so far now. So thank you for getting into this deep 4D tutorial, because I want to put it in English. So I think it is going to help you a lot in visualizing the 4D. Thank you.